The universe is filled with monsters that devour everything in their path. We call them black holes, and their hunger is infinite. But physics demands a balance, a mirror image to this darkness. What if there exists a place where time flows backward and nothing can ever enter? Welcome to White Holes. In 1916, Carl Schwarzschild discovered the mathematical heart of a black hole. Hidden within those same complex equations was a shocking anomaly. If you flip the math, you find a region of space that only ejects energy. It is a cosmic fountain, but where does its endless stream of matter originate? A black hole's event horizon is a point of no return for anyone falling inside. However, a white hole's horizon acts as a physical shield. It repels every particle and photon with an unstoppable force. It is the ultimate no-entry sign of the cosmos. But why does nature forbid entry? In the world of white holes, the laws of time are fundamentally broken. While we experience time moving forward, these objects theoretically function as a black hole played in reverse. They are a ghost of the past, pushing everything away. Could this mean that time itself is not what we think it is? Traditional physics struggles with the existence of white holes because they seem to decrease entropy. Our universe usually moves toward chaos, yet a white hole creates order by organizing and ejecting energy. Does this mean they exist outside our standard laws of thermodynamics? Or is our understanding of energy simply incomplete? If a white hole is constantly vomiting light and matter, it must have a source. Since nothing can enter from our side, the energy must come from elsewhere. Is it possible that these objects are connected to a hidden reservoir of matter located in another dimension? The answer leads us to wormholes. Imagine a tunnel carved through the very fabric of reality. At one end, a black hole swallows a star. At the other end, a white hole screams that star back into existence. This bridge suggests that every black hole might be an entrance to a different part of the vast, infinite multiverse. If they are so powerful, why haven't we photographed one yet? Calculations suggest white holes are impossibly fragile. The moment any tiny amount of matter even touches their repulsive field, the internal pressure could cause an instant collapse. Are they destined to vanish before any human eye can ever perceive their brilliant light? Look at the birth of our own universe. A single point suddenly exploded, releasing all matter and energy into a silent void. This description perfectly matches the mathematical profile of a white hole. Could it be that we don't see white holes because we are currently living inside the aftermath of one? In 2006, a mysterious flash of gamma radiation baffled NASA's telescopes. It didn't behave like a dying star or a merger. It was a prolonged, violent eruption from an empty region of space. For a moment, astronomers wondered, did we just witness the brief life of a real, physical white hole? Modern physics suggests a black hole doesn't last forever. As it collapses to a microscopic point, space itself might become too compressed to hold. This causes a quantum bounce, where the collapse turns into an explosion. The black hole literally turns inside out, becoming a white hole over eons of time. Stephen Hawking famously worried that black holes destroy information, which breaks the rules of quantum mechanics. White holes offer a brilliant solution. If everything that enters a black hole eventually exits through a white hole, information is never lost. It is simply recycled. But what form does that recycled matter actually take? Nature loves pairs, matter and antimatter, positive and negative. If the black hole is the ultimate symbol of death and destruction, the white hole must be the ultimate symbol of birth and creation. Without them, the universe feels lopsided and incomplete. Is our galaxy hiding these fountains in its darkest corners? Some researchers believe white holes are actually highly magnetic remnants of dead black holes. These magnetars could be pushing matter away so fast that they mimic the properties of a white hole. But if magnetism is the cause, why do the equations of relativity insist on a much more mysterious spatial explanation? The search for dark matter has led some to a startling conclusion. Microscopic white holes, created during the Big Bang, could be the invisible mass holding galaxies together. They would be too small to see, but heavy enough to influence gravity. Are we surrounded by billions of tiny, invisible cosmic exit doors? Scientists are now creating sonic white holes in laboratories using sound waves in specialized fluids. These experiments prove that repulsive event horizons can exist in a controlled environment. If we can build them with sound, is it only a matter of time before we find them built with the fabric of space? Every time a black hole forms, a new universe might be born on the other side through a white hole. This creates an infinite chain of baby universes. If this theory is correct, our own existence is just one link in a never-ending cycle of cosmic death and spectacular, bright rebirth elsewhere. The existence of white holes would mean that the universe is not destined for a heat death. Instead, it could be a self-sustaining engine that never stops. Every ending becomes a new beginning. Does this mean the cosmos is an eternal machine, or is there a limit to this cosmic recycling? We are currently scanning the skies for high-energy anomalies that defy traditional explanations. New telescopes like the James Webb are looking for white shadows in the early universe. Each data point brings us closer to a truth that could rewrite every textbook we own. What will we do if we find one? White holes represent the ultimate frontier of human knowledge. They are portals where math meets mystery and where the end becomes the beginning. Do you believe these cosmic fountains are real, or just a beautiful dream of Einstein? Like this video, subscribe to World of Mysteries, and share your theory below.